Hey guys, it's Coach Brian going over the 5.7 notes with you. I'm going to try really hard to make this fast since my last notes were so time consuming. And so if you have any extra questions after you watch these, just make sure you ask your teacher, look at your notes, look at your practice, and look at all the other resources that your teacher shared with you. So let's get started. For examples 1 and 2, we're trying to list the angles and sides of a triangle in order from largest to smallest. So first of all, make sure you always look at those words and make sure that you are carefully reading the order that they want you to go in. Second thing, you need to know these two things about a triangle. The largest sides are across from or opposite of the largest angles in degrees. And the reverse of that is also true, that the smallest sides are also across from the smallest angles. So that's true both ways. And then you could also say the smallest sides are across from the smallest angles. So if we go look at this first example, it wants us to list the angles, and we don't have any angle values in this triangle. All right, we don't know anything about them, but we do know the sides, and we know that the shortest side is across from the shortest angle, and the largest angle is across from the largest side. And knowing that information, we can put the sides in order. So QR is the longest side, PR is the next longest side, and then QP is the shortest side. And we would say, what angle are these across from? And so Q to R is on the other side of angle P. P to R is across from angle Q, and Q to P is across from angle R. So now we've got our angles listed in order from largest to smallest. And then we would just do the opposite for the next question. We know the angles now, and the smallest angles are across from the shortest sides. We're still listing them from largest to smallest, so let's focus first on the biggest angle, angle L, and see what it's across from. It's across from KM. The second biggest is 35. It's across from LK. And then the smallest is 22, which is across from LM. So those are our sides in order from largest to smallest. All right, for this next one, we're given some sides of a triangle. And the first thing we need to do is to take their three sides and put the shortest one, the longest one, and the one that falls in between those. And then we have to decide if it's a triangle. And so I'm just going to do the first three for you right here, and I'll let you do the rest. But a little piece of helpful information is down here, the triangle inequality theorem. The sum of two sides of a triangle is greater than the third side. If that's true, these are a triangle. So what would that look like? Well, if I take 4 and 5 up here and I add them together, that equals 9. And 9 is greater than the third side of the triangle. So yes, this is a triangle. Now, you could do it with any two sides, so I could say 6 plus 5 is greater than 4. That's true. I could say 5 plus 6 is greater than 4. That's true. Pretty much any way on this first example that you do this, yeah, that's going to be a triangle. If I look at number 1, I've got 3 plus 4, and that equals 7, and 7 is also greater than 5. So yeah, that's also a triangle. And if I look at, number 2, I add 2 and 3, and that equals 5, and 5 equals 5. And this theorem doesn't say is greater than or equal to, it just says is greater than. And since 5 is not greater than 5, then no, this is not a triangle. So on your own, I want you to do 3 through 8, and then see if you can come up with any kind of observation about the sides of a triangle that do work. So the ones that are all a yes. See if you come up with any observation between those. All right, moving on. For example number 4, we are trying to come up with an inequality that expresses what the third side of this triangle could be. So remember, for inequalities, we're going to use signs like less than, greater than, less than or equal to, greater than or equal to. And to start off with, it says an angle has two sides of 5 and 8. Write an inequality to represent the third side. Well, based on the theorem we just read, the sum of any two sides is greater than the third side. So the two sides we have are 8 and 5. 8 and 5. So 8 and 5 is 13. And the third side has to be less than 13. So we know that for sure. It has to be less than 13. But it also has to be greater than 8 minus 5, which is 3. The reason it has to be greater than 3 is because if it was, let's just say it's 3. We have a triangle with sides 8, 5, and 3. You can add up any two sides and they should be greater than the third side. So if I had 3 in there and I had, 5 plus 3, that's 8. Well, 8 equals 8, which means that wouldn't be a triangle. So this has to be greater than 3, but also less than 13 to follow the rule of the inequality theorem that we just learned. So the way we would write this is if the third side, we could just call it, side. It has to be greater than 3. It has to be less than 13. And so we have our inequality written just from kind of working through and talking through. We were able to write an inequality. All right. Example 3, a triangle has two sides, 7 and 10. Write an inequality to represent the third side. Well, the same thing. It's got to be greater than 10 minus 7, which is 3. It's got to be less than 10 plus 7, which is 17. And so our third side of the triangle must be greater than 3. I'm just going to call the third side x, and less than 17. All right. Example 6 and 7. Use the inequality AB plus AC is greater than BC. That's just the theorem that we just learned, written as a little formula, to set up and solve the relationship between the sides of the triangle below. Excuse me. So AB is 4x minus 4. And we're saying that if you added that to AC, which is 3x minus 2, it would have to be greater than BC. And I didn't give myself enough room here to write, so let me squeeze all this together real quick. All right. 4x minus 4 plus 3x minus 2 is greater than 5x minus 2. All right, so when we are solving inequalities, all right, we need to, similar to solving, start on the left side by combining like terms. And so we have 7x over here. And with our whole numbers, we have -6. And we're still saying that that's greater than 5x minus 2. We want to move the 5x over. That will leave us 2x. And we want to move the 6 over. That will leave us 4. 2x is greater than 4. And then the last step is to divide by 2. And we get that x is greater than 2. And so up here, x is greater than 2. This value, x, has to be greater than 2 for this triangle theorem to remain true. And we'll do the same thing for example 7. We're doing AB, x plus 3, plus AC, x plus 2, is greater than 3x plus 2. So for this one, we would combine our like terms. 2x plus 5 greater than 3x plus 2. And for this one, I'm going to move the 2x over. That will leave me with x. I'm going to subtract 2. That will leave me with 3. And I didn't do any operations to change my sign. So my final answer is x is less than 3. Less than 3. So I would put x is less than 3. And that's all. So hopefully this was a little less stressful than 5-4, 5-5, 5-6. And like I said, if you have any questions, make sure you ask your teacher and use all the resources they're giving you, the notes, these videos, any extra help, IXLs, things like that. Use it all. Y'all have a good day.